Alright, to pick up right where I left off, it is pentanol, but it is on the 2 carbon, so it would be 2-pentanol. Indicate that it's there. Alright. Next one. Alright, here's a little alcohol when you have a benzene ring attached. And this makes its own functional group. So it's actually kind of interesting. You have a functional group that stems from 2 other functional groups. But alright. Now this can be written one of 2 ways. This is a phenol. And sometimes you'll see the benzene ring written. This is how I personally like to write it, with just a circle in the middle and your OH phenol coming off right there. And so this right here is what we call a phenol. Alright, let's look at some more examples. Aromatics and benzene. So what happens if we have something like my OH here and a bromine, and we'll just go like that. Alright, so when we look at this molecule here, we have to realize this is a benzene ring with an OH. So it is going to end with phenol. And it is a, so that the phenol part takes care of the fact that it's a benzene ring with this attached. So now we want to order again, and 1, 2, 3, 4, 5, 6. So on our 2 one we have a 2, and remember, alphabetical order, this is a bromo, which we'll get into later, and this is a 1,2 carbon chain, so that's an ethyl. So B comes before E, so it's going to be 2 bromo 2, I'll just rewrite this over here, 2 ethyl phenol. And that's how we would write that. Just get rid of this. Alright. Moving on. Carbonic acid. Carbonic acids are, as we'll see later, they're up towards the top of the chart in terms of precedence. They're very similar to aldehydes, except with the addition of the oxygen, forming an acid. Any of these compounds are oic acid. And now to take a look, whoops, one second, pause this. Alright, now to take a look at the actual carbon right here. This right here, and this is common in a lot of other functional groups, this right here is what we call our carbonyl. And so we have our carbon double bond to our oxygen, and then we have our alcohol right here over here, and since it's combined we call it a carbonic acid. Alright, now let's look at some more, a little more in-depth examples. We have, we'll take a look at this one first here. Again, we always want to start with the carbon that is in the carbonic acid, and that's this one right here. So we go 1, 2, 3, 4. So we have butane, and then remember from our previous slide, our ending is oic acid. Simple as that. Alright, look at this one. Basic same, except now all of a sudden we have a double bond here at the 3. So again, start with the carbon that is in the carbonic acid. 1, 2, 3, 4, 5, 6, 7. So we have a root of hept. And remember, we have our double bond at our 3. So it'll be 3 heptene. Also could be written, let me scratch that. 3. Either or of these is acceptable. And now we have our alcohol, or our carbonic acid at the end. So we'll just write it 3 This is oic acid. And that is our molecule right there. Right. Next one. Cyclos and hexenes plus alleles and vinyls. Simple aromatic ring with all carbons being single bonded. Ending is ane, just like in all our alkanes, and our prefix is going to be cyclo. So we have the term cyclopentane. From the word, we can write what this is. We know it's in a ring shape. 1, 2, 3, 4, 5. Okay. That is bad. Alright, one sec. Usually just make a little pentagon in my mind, so we'll just stick with that then. Not exactly what it looks like in chemistry terms, but it'll work. 1, 2, 3, 4, 5. And there you go. Cyclopentane. Easy stuff. So, now let's take a look, and we'll write one that has an allele and a vinyl coming off of it. So, let's just do right here. 1, 2, excuse my mom. So now we have this right here, and then we have one like this. 1, 2. And so now we have something different, and these are just commonly known. Doesn't really matter how you order this. You can go 1, 2, 3, 4, or you could go 1, 2, 3, 4. When you look at this in a 3D-dimensional, those two parts can be interchanged, so it's not really that big a deal. What is important though is that we recognize this as being a vinyl, and this is an allele right there. And so if we were going to write this out, we could write it, and I'll just write the one that's in red here, 1, 2. I'll just go with that writing, and we go, if we're going to label this, we'll go 1, we have 1 allele, 2 vinyl, cyclo, since it is a ring, butane, since they're all single bonds. These are all single bonds in this one right here. So that's how you name that particular one. Okay, moving on. Cyclohexene, again, just like our cyclohexane, except now, just like in the other ones, we have an ene ending, so it's a double bond. So we'll just take a look at something like this one, 2, 3, 4, 5, 6, 7. This is not symmetrical. Oh, what do you know that? Looks like a stop sign, it's in red. Look at. Alright, so let's see. We want to put a couple double bonds in here. I'll put one here, and I'll put one here. And then we can put chlorine coming off here. And we can have this, and we'll just make this right here. Alright, so how would you go about naming something like this? Well, you have to know that in order of precedence, the chlorine is going to come first. So this is going to get to 1, and then we're going to go this way, 2, 3, 4, 5, 6, 7, and here's 8. And the reason we do this is because we have a branch here. We do have a double bond both places, but this branch is going to make us go in the clockwise direction. So we're going to label this. It'll be cyclo and then hexene. And we also, now we're going to put our double bonds. Our double bonds are at 2 and 7. So 2, 7. And now we also have to worry about our chloride, which is at our 1. And we have this right here. Can't remember if we talked about this or not. But we actually have 1, 2, 3 carbons here, but it forms a Y shape. So this is what we call an iso. And so this is going to be isopropyl. So our chlorine is going to come first since C comes before I. So when we're going to write all this out, I'm running out of room, so I'll just write this down here. We have chloro 4 isopropyl 2, 7 cyclohexene. Run off the page. Alright, man, those names get long. Now moving on, next we have ethers. Alright, so now we're looking at ethers, and there's really 2 ways you can look at naming this. The first way is the common way, common naming, and this is what obviously is used a lot, and it works great for simple ones like I have right here. So I have this molecule 1, 2, 3, so propyl, and I have a 1, 2, 3 propyl again. So the naming behind this is very easy. Dipropyl, di being 2, propyl, and then ether. So you just put what it is at the end. So now you have, let's take a look down here in the next one. We have a 1, 2, 3. And remember, just like the last slide, this is an isopropyl, and we have 1, 2. So it's an ethyl. So if we were going to name this, the actual correct naming, remember, alphabetical order, would be ethyl isopropyl. That'd be the naming for this. Ether. Oh, wow. Almost missed the most important part there. Ethyl isopropyl ether. So now we're going to take a look on the next slide and look at the IUPAC naming for this. And this is what's used a lot when you are starting to get into longer carbon chains dealing with ethers included in them. So we look at our first chain here, and we have a chain of 1, 2, 3, and so we have the term prop, and then we have 1, 2, so that's eth. And before I go on too far, I want to take here and highlight this. Longest chain remains AN ending, and the shorter branch receives the oxy ending. So when we take a look at here, our shorter end would be our 1, 2, so that's our ethane, so that's replaced with an oxy ending. And our longest chain, which is 3, 1, 2, 3, keeps the propane ending. So the oxy is really the main difference when we're looking at the IUPAC naming for ethers. So now we're taking a look over here. We have a meth, and this is going to be 2 methoxypropane. So as you can see, 1, 2, 3, you got your propane, and doesn't matter that it's an isobutyl anymore because the branching, the way it comes off, it's not important in the IUPAC naming. So moving on, epoxies. Simple definition of epoxy is an oxygen atom enclosed in a carbon ring. Prefix is epoxy.